Here is a lesson on graphing the cube root functions. We'll start off by graphing the parent function for the cube root. So we have our relation, y equals the cube root of x. We're going to go ahead and create a t-chart, so x and y. Remember to find the ordered pairs. We're going to evaluate for different x values. I'm going to start with 0. So this cube root of 0 is 0. Now we'll choose 1. Cube root of 1 is 1. Reason why is 1 is a perfect cube, because 1 times 1 times 1 is 1. Now if I choose numbers like 2, 3, 4, 5, 6, or 7, those would not be nice integers as their output. You'd have to use your calculator in order to find those values. So I'm going to jump up to 8. I'm going to say the cube root of 8. Now if you remember, when you break down this cube root, 8 is the same thing as 2 times 2 times 2, or 2 cubed. The index and the power of this radical are going to undo each other, so you're left with just 2. So we have the ordered pair 8, 2. All right, now I'm going to go to the negative values, -1 and -8. So the cube root of -1, -1 times -1 times -1 is -1. So the cube root of -1 is -1. All right, now again, just like when I jumped ahead with 2, 3, 4, 5, 6, 7, I'm going to jump ahead to -8. -8, the cube root is going to be -2. The reason why is -2 times -2 times -2 is -8. They undo each other, so you're left with -2. All right, so let's go ahead and graph these ordered pairs. Over 0, 0, then over 1, up 1, and then over 8, up 2, and then left 1, down 1, left 8, down 2, and you'll see your graph look like this, which is called our cube root function. Looks like the shape of a snake. All right, there's our parent. These next 2 slides I'm going to go a little bit quicker with. Remember, there are some transformations on the vertical axes. So if you have a plus d at the end, it's going to shift all of your y values up from its parent. If you have a minus d, it's going to subtract, move down all the y values. All right, now we're talking horizontal. So it's going to be now inside the cube root. So if it's a plus c, you have to think opposite. You're going to subtract c from the x-coordinates. If it's a minus c inside the cube root, you're going to add c to all the x-coordinates. All right, let's practice this now. So we give you the function g of x equals the cube root of x plus 3. So I'm going to take care of the parent first. So our parent is y equals the cube root of x. I'm going to go a little faster with that since we just graphed it. So when we substituted 0 in for x, we got 0. When we substitute 1 in, we got 1. When we substitute 8, the cube root of 8 is 2. And then -1, -8, the cube root of -1 is 1. Cube root of -8 is -2. So I'm just going to go ahead and graph that quickly. All right, so there's our coordinates graphed out. Now we need to figure out what our transformation is. Notice that this plus 3 is outside the graph. It's going to affect the y-axis, and it's going to push everything up 3 units. So we're going to take all of these values in our y, and we're going to add 3 to them. So 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. -1 plus 3 is 2. -2 plus 3 is 1. All right, are we going to do anything with the x values? No, we are not changing the horizontal axis, so all of these numbers are just going to repeat. So 0, 1, 8, -1, -8. Now let's go ahead and graph it. So our first order pair is over 0. up 3. Next one, over 1, up 4. Next one, sorry about that, negative 1, up 2.
Instructor teaching driver's ed, please call 3780. The instructor teaching driver's ed, please call 3780.
All right, there we go, we are after school. So now it's over 0, up 3. All right, so parent function is the cube root of x. The name of it is cube root, or root. The transformation that happened was it's shifting up 3 units, and the critical point is the over 0, up 3 point. All right, let's do one more of these. So we'll graph the parent first. I'm going to go fast with that. You can pause if you want to and try it on your own. Okay, we're evaluating the function. Square root of, or cube root of 0, 0. Cube root of 1 is 1. Cube root of 8 is 2. Cube root of negative 1 is negative 1. Cube root of negative 8 is negative 2. Graph it out. All right, we have 2 transformations here. The first one is outside the function. It's going to affect the y-axis. It's a +1, so it's going to shift everything up 1 unit. So we're going to add 1 to all of our y values. So all of these y values, we're going to add 1. So 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Negative 1 plus 1 is 0. Negative 1 plus 2 is negative 1. All right, now let's go inside the cube root. That's a -2, so you have to think opposite. That's going to shift it to the right 2 units. So in order for us to go to the right 2 units, we have to add 2 to all of our x values. Now we're going to take that original x ordered pairs, we're going to add 2, so +2. So 0 plus 2 is 2. 1 plus 2 is 3. 8 plus 2 is 10. Negative 1 plus 2 is 1. Negative 8 plus 2 is negative 6. All right, let's graph it out. I'm just going to change colors here. So this will be my actual function, my g of x. So over 2, up 1. Over 3, up 2. Over 10, up 3. Over 1, up 0. Negative 6, down 1. This is our critical point. 2, 1. All right. So our parent function was the cube root of x. There are 2 transformations. We went right 2 and up 1. Critical point 2, 1.